In this lecture, we are going to discuss about a nuclear fission reaction or nuclear fission process. Nuclear fission process is a process in which one unstable atom or unstable nuclei is converted into two or more than two daughter nuclei. A nuclear fission reaction may be defined as a nuclear reaction in which a as unstable atom is converted into two or more than two stable atoms, and during the conversion of unstable atom into two or more than two stable atoms, there is a release of energy. So such type of reactions are known as nuclear fission reactions. Dear students, please keep in mind that usually people believe that nuclear fission reaction usually take place in uranium-235, but dear student, please keep in mind that there are some elements whose atomic number is in the range of 19 to 100, so their nuclei are also unstable. So the nuclear fission reaction is also possible in uranium, in all those elements having an atomic number in the range of 19 to 100. So now consider the nuclear fission reaction in uranium-235 atom. Consider this is a schematic representation of a nuclei of uranium-235. The red represent proton, whereas the white region represent neutron of nucleus of uranium-235 235 atom. Please keep in mind that uranium-235 atom is basically unstable atom. It is pretty unstable. And when a neutron is slammed or neutron is incident on, consider this a neutron, when a neutron is incident on uranium-235, uranium-235 nucleus basically accommodate the incident or slam neutron. So the uranium-235 by accommodating neutron will be converted into uranium-236. Please keep in mind that during the uranium-236 is even more unstable than uranium-235. The lifetime of uranium-236 is very short, and that is the reason the uranium-236 will basically abruptly or spontaneously or in a very short amount of time, due to its instability, it will be converted into two stable nuclei. One nuclei will be a beryllium 144, and whereas other nuclei or other atom will be krypton 89. So during the conversion of uranium-236 into beryllium to barium 144 and krypton 89, there will also be a production of three additional neutrons, and as well as high amount of energy will be released during this nuclear reaction. Dear student, please keep in mind that the role of neutron is very important in nuclear fission reaction. Basically, the production of neutron can further basically cause a nuclear reaction with other uranium atom, and they can further develop this reaction continuously in a form of a nuclear chain reaction. So in a simple word, if I conclude a nuclear fission reaction in uranium atom, basically a neutron is slammed on uranium-235. The uranium-235 nuclei absorb or adjust neutron, and uranium-235 is converted into uranium-236. Uranium-236 is more unstable than uranium-235, and uranium-236, due to instability of uranium-236 atom, the uranium-236 atom will be converted into a barium atom, barium 144, and as well as daughter atom krypton 89. Along with the conversion of daughter atoms, along with the conversion of unstable atom into two daughter atom, there will be a production of neutrons along with high amount of energy. So this will be a nuclear reaction in uranium atom. So now, dear student, let us represent a nuclear reaction. Let us write a nuclear reaction of a nuclear fission reaction for uranium atom. Since you know that in uranium atom initially a neutron is incident on uranium 235. So when uranium 235, when a neutron is incident on uranium 235, uranium 235 is converted into unstable, very unstable uranium 236. Since the uranium 236 is very unstable, then this uranium 236 is converted into barium and as well as krypton. Along with this, basically, student, uranium atom will also produce 3 neutrons and huge amount of energy. Now, question here is that this student is only is this type of only reaction take place just uranium is converted into barium or and krypton? Is it not possible that uranium neutron interact with uranium in different way and produce different types of element? Yes, it is possible. Uranium, there is a possible that in some cases uranium when interact with a neutron, they may produce rubidium and cesium, and in some nuclear reaction they may produce strontium and xenon. Now suppose that a neutron is incident on uranium 235 and uranium 235 is converted into uranium 236, and there is a possibility that uranium 236 is split into rubidium 90, and as well as cesium plus 3 neutrons and release a high amount of energy. Similarly, there is another type of interaction also possible in which a neutron is interact or it's neutron slammed uranium 235 atom, and it causes the change in uranium 235 into uranium 236 atom, and this uranium 236 is very unstable, and it is converted into strontium 38 and 90, strontium 90 plus xenon plus 3 neutrons and as well as huge amount of energy. So this means that an uranium 235 may be converted into a barium and krypton, rubidium and cesium, strontium and xenon, but the conversion of uranium 235 or splitting of uranium 235 into these depend on the way of interaction of neutron with a uranium atom. Now, the student, please keep in mind that question here is that is it possible that a nuclear fission reaction take place without uranium? Dear student, for nuclear fission reaction, there is the requirement for nuclear fission reaction is the requirement for nuclear fission reaction is unstable atom. So any type of unstable atom there is a possibility of fission reaction in those atoms. However, most commonly nuclear fission reaction take place in elements or atom having an atomic number between 90 and 100. So this means that nuclear fission reaction is not limited to uranium. There are other elements possible having a heavy atomic number and it's in the range of 90 to 100. They can also cause a nuclear fission reaction. Now, question here is that you student please keep in mind that nuclear fission reaction is usually take place or is used in different ways. It may be used in nuclear power plants, power plants, nuclear fission reaction may be used in nuclear submarines, and it is also used in nuclear bombs. So now, dear student, let us discuss that how nuclear reaction, basically nuclear fission reaction, take place in nuclear bomb, nuclear power plant, or in nuclear submarine. Dear student, as you know that in nuclear reaction, initially a neutron, let me make it small. Initially, dear student, a neutron, suppose this is a neutron, N is smashed, is basically incident on uranium atom. So now when a neutron incident on uranium, basically due to the unstable nature of uranium, uranium will be converted into a daughter nuclei. But however, along with the conversion of daughter nuclei, uranium will also be converted or split it, or uranium will also produce 3 neutrons. These neutrons will again further react with another uranium atom, and due to reaction of with of neutrons or due to interaction of neutron with other uranium atoms, The uranium atom will be basically converted into daughter nuclei, and as well as along the conversion of uranium atom into daughter nuclei, these uranium atom will also produce further three more neutrons. So basically a bunch of amount or huge amount of neutron will be produced, and these neutrons will again and again interact with uranium atom, and they will cause the production of huge amount of energy. And the reaction in which continuous neutrons are produced, and they react continuously with unstable uranium nuclei and produced huge amount of energy continuously, is known as nuclear chain reaction. So in this way, a continuous amount of energy will be released, and continuous reaction will take place. So in case of, dear student, in case of nuclear bombs, the amount of uranium 235, is varied. If we use huge amount of uranium 235, then it will basically release huge amount of energy. So in order to control a nuclear fission reaction, dear student, the less amount of uranium is used in nuclear reaction. However, similarly, in case of nuclear power plants, and as well as nuclear submarines, the amount of uranium used in during the nuclear fission reaction is basically used in controlled fashion. Another question here is that in some cases there is a possibility that we achieved a desired result. Then how we can basically control the nuclear fission reaction? In such cases, there is called a chemical known as a soaking chemical. It is used to basically soak neutron during the nuclear reaction, and by the soaking electron, the amount of electron in a chain reaction basically it decreases, and in this way the interaction amount of neutron is basically decreases, and in this way the interaction of neutron is basically with uranium is in control fashion, and it is limited. So in this way the amount of energy during a nuclear fission reaction is controlled. So now let me conclude the nuclear fission reaction. Nuclear fission reaction is a reaction in which a in which a parent atom or a parent nuclei which is unstable is splitted into two or more than two stable nuclei along with huge amount of energy. Nuclear fission reaction usually take place in uranium atom. However, it may take place with elements having atomic number range from 90 to 100. Nuclear fission reaction in nuclear power plant or nuclear bombs or nuclear submarine take place in a form of a nuclear chain reaction. And in nuclear chain reaction, a neutron basically continuously interact with uranium atom, and it's continuously produce huge amount of energy. So dear students, this is all about the nuclear fission reaction. So thank you for watching this lecture.